We have one of them, 3i Atlas. It's a blind date, and in blind dates, especially those from interstellar space, we should observe before expressing an opinion about the nature of the other side. And so that's my advice.
Scientists are panicking. And when scientists panic, they don't scream or run. They use words like unprecedented and exceptional in their papers. They add supplementary figures where they quietly question everything they thought they knew. Right now, those words are appearing in study after study about a single object. Its designation is 3I/Atlas, and with every new measurement, it becomes more impossible to explain. Something is moving through our solar system. It came from the void between stars, and it's breaking rules we didn't even know existed. This isn't speculation. This isn't science fiction. This is happening right now, documented in peer-reviewed papers, tracked by telescopes across Earth. An interstellar visitor is exhibiting behavior that has never been observed before, not once in the history of astronomy. And the more data we gather, the stranger it becomes. Let me take you back to July 1st. The Atlas Survey Telescope in Chile detected something. In the vast darkness of space, moving against the background stars, something appeared. The astronomers designated it 3I/Atlas. The 3I stands for something profound. This is only the third interstellar object humanity has ever detected entering our solar system. Think about that for a moment. In all our years of watching the heavens, scanning the skies with ever more powerful instruments, we've only seen 3 visitors from beyond our cosmic neighborhood. The first was Oumuamua in 2017, a cigar-shaped mystery that sparked worldwide debate. The second was Borisov in 2019, which behaved more like what we expected from an interstellar comet. And now there's 3I/Atlas. But how do we know it's truly interstellar? The mathematics are unambiguous. Astrophysicists can calculate exactly where an object came from by tracing its trajectory backward through space and time. They can measure its velocity, its angle of approach, its orbital characteristics. And every calculation points to the same conclusion. 3I/Atlas is not gravitationally bound to our solar system. It came from somewhere else. Some wondered if it might have originated from the Oort cloud, that vast spherical shell of icy objects surrounding our solar system like a cosmic cocoon. Occasionally, something from the Oort cloud falls inward, becomes a comet, gives us a spectacular show in our skies. But objects from the Oort cloud have a characteristic signature, very small initial velocities as they begin their long fall toward the sun. 3I/Atlas doesn't fit that profile, not even close. Its velocity is far too high. Its trajectory is all wrong. The numbers don't lie. This object came from interstellar space, traveling between the stars before it happened upon our solar system. This much is certain. So the question becomes, what exactly is it? At first, the answer seemed straightforward. Most astrophysicists initially classified it as a comet. A comet is a body composed primarily of ice and rock. As it approaches the sun, the ice begins to sublimate, turning directly from solid to gas. This creates the characteristic tail we associate with comets, streaming away from the sun like cosmic hair blown by stellar wind. If 3I/Atlas is a comet, it should behave like a comet. It should follow the rules. It should be predictable. Comets are beautiful, but they're also well understood. We've studied thousands of them. We know their chemistry, their physics, their behavior. But 3I/Atlas isn't following the script. The first anomaly appeared in the spectroscopic data. When scientists analyze the light from a celestial object, they can determine what elements and compounds it contains. Each element has a unique spectral signature, like a fingerprint made of light. For 3I/Atlas, those fingerprints revealed something extraordinary.
One solution to that paradox is called the dark forest hypothesis, where they exist out there, but those that survived are careful, they're silent to avoid predators. And they were bruised by encounters in the past, and therefore they just observe rather than make a sound. We were careless. We were broadcasting radio signals for more than a century.
A recent study published on the Archive reported findings that made astronomers sit up and take notice. 3I/Atlas is shedding nickel and iron, not unusual amounts, not slightly elevated levels. The paper describes the rate as exceptional. That's not a word scientists use lightly. In the careful, measured language of scientific literature, exceptional means something has shattered expectations. Comets don't typically shed heavy metals at exceptional rates. They're made of ice, dust, organic compounds, light materials, volatile substances. Finding massive amounts of nickel and iron streaming off an interstellar comet is like finding a stream that flows with mercury instead of water. It's chemically bizarre. But the strangeness doesn't end there. The same study revealed another anomaly in the atmospheric composition. 3I/Atlas is emitting both carbon dioxide and water vapor. This isn't unusual in itself. Many comets do this, but the ratio between the two compounds has been described by researchers as unusual. Again, that word, unusual. In science, when something is labeled unusual, it means it doesn't fit known patterns. It means the data is telling us something we haven't seen before. And here's where it gets truly interesting. Some researchers have noted that this particular ratio of carbon dioxide to water would be consistent with exhaust from a propulsion system. Let that sink in for a moment. A propulsion system. Yet another paper added to the mystery. Researchers studying the optical properties of 3I/Atlas discovered something they called unprecedented among asteroids and comets. The object changes the polarization of light in a way that has never been observed before. Light waves oscillate in different planes, and when light bounces off or passes through an object, its polarization can change in predictable ways. We've studied countless asteroids and comets. We understand their optical properties. 3I/Atlas is doing something different, something unprecedented. There's that word again. And then there's the tail, the impossible backwards tail. 3I/Atlas is still far from the Sun. At this distance, if it's truly a comet beginning to sublimate, it should be developing a tail. And that tail should point away from the Sun, blown by solar radiation and the solar wind. This is fundamental physics. This is how comets work. This is what we've observed countless times.
And those signals must have reached them. So at some point, if they see us as a threat, because we are a young technological civilization, they might visit us. And for example, 3I/Atlas took about 8,000 years to reach us from the outskirts of the Oort cloud of the solar system.
But 3I/Atlas has developed a tail pointing toward the Sun, not away from it, toward it. Astrophysicists have described this as not common and possibly observed for the first time. Some are being even more direct. This might be the first time in history we've seen this phenomenon. How does a tail point toward the Sun? What force could cause material to flow in the opposite direction of what every law of physics predicts? The implications are staggering. All of these anomalies exist against a backdrop of an already unusual trajectory. 3I/Atlas entered our solar system on a path almost perfectly aligned with the ecliptic plane, the flat disk in which Earth and the other planets orbit. For an object coming from interstellar space, from a random direction in three-dimensional space, to arrive almost precisely in this plane is statistically improbable. And its journey through our system takes it close to three major planets: Mars, Jupiter, and Venus. On October 29th, it will reach its closest approach to the Sun on the opposite side of our star from Earth. And throughout this journey, it's moving unusually fast. Faster than the previous interstellar visitors, faster than expected. Some researchers have even suggested it doesn't appear to be tumbling as much as one would expect from a natural object. Others have noted what might be self-illumination. These claims remain more speculative, existing somewhere in the realm of the Oort cloud itself, but they add to a growing pile of observations that simply don't fit. Let's pause and consider the language appearing in these scientific papers. Exceptional, unusual, unprecedented, observed for the first time, not common. These aren't words scientists scatter casually through their research. These are red flags. These are carefully chosen terms that signal something is fundamentally not matching our models and expectations. How many anomalies does it take before we must seriously consider alternative explanations? The mainstream scientific explanation remains that 3I/Atlas is simply an unusual comet. A comet unlike any we've ever seen, but still a natural celestial body. After all, this is only the third interstellar object we've ever observed. We don't have a large sample size. We don't know what's normal for interstellar visitors. Perhaps they're simply different from the comets born in our solar system.
100,000 times the Earth-Sun separation. And that was, 8,000 years ago. That's when humans started to document their history. That's not very long ago. And if this is a spacecraft, if it started its journey about 1,000 times the Earth-Sun separation.
This is reasonable. This is the conservative, scientific approach. When faced with unusual data, first look for natural explanations. Expand your models. Consider that your understanding might be incomplete rather than fundamentally wrong. But there's a counterargument worth examining, and it involves understanding how science can fail. Scientists tend to be very concerned about type 2 errors. A type 2 error occurs when you have a false hypothesis and you fail to reject it. You believe something wrong because you didn't gather enough evidence to disprove it. The classic example, someone claiming vaccines cause autism. Scientists are trained to attack these errors relentlessly, demanding extraordinary evidence, wielding their hammer labeled insufficient evidence. But there's another kind of error. A type 1 error happens when you have a true hypothesis and you reject it. You dismiss something real because it seems too unlikely or too uncomfortable. The classic example from medical history, the idea that bacteria could cause cancer. This was dismissed for years, considered implausible, rejected by mainstream medicine. Those who proposed it were marginalized. The hypothesis was true, but science rejected it. Type 1 errors are insidious because once a hypothesis is rejected, scientists stop thinking about it. It falls out of the conversation. It doesn't attract attention or funding. The consequences of missing a truth can persist for decades. And this brings us to the elephant in the room, the hypothesis that scientists are most reluctant to seriously consider, the one that gets you labeled as fringe or attention-seeking, the possibility that 3I/Atlas might be artificial, not a comet, not an asteroid, technology. Let's be absolutely clear about something. We have no direct evidence that 3I/Atlas is alien technology. None. The most scientifically rigorous position is that it's probably a natural object we simply don't understand yet. But here's the uncomfortable question. What if our reluctance to seriously investigate this possibility is precisely the kind of type 1 error that could haunt humanity forever? Think about the galaxy we inhabit. 400 billion stars, countless planets. The laws of physics are the same everywhere. The chemistry is the same everywhere. If life emerged on Earth, if intelligence evolved here, why would we be unique? The galaxy is ancient, 13 billion years of stellar evolution, planet formation, the endless march of time and chance. Other intelligent civilizations almost certainly exist, or existed. And if they exist, they explore, they send missions, they build technology. And over millions of years, that technology fails, breaks down, becomes debris, space junk, interstellar wreckage drifting through the galaxy. The probability that a piece of alien technology would drift through our solar system at this exact moment in history is extraordinarily low, but it's not zero. It's never zero. And given the sheer age and size of the galaxy, given the number of civilizations that might have risen and fallen, the amount of technological debris drifting through interstellar space could be substantial. Consider what we're observing: the unusual chemical composition, particularly the exceptional rate of nickel and iron emission. Heavy metals are exactly what you'd expect from technological debris, from machinery breaking apart. The unusual ratio of carbon dioxide to water, resembling propulsion exhaust. The unprecedented optical properties that don't match natural materials we've studied. The backwards tail that defies conventional physics. The trajectory nearly aligned with the ecliptic plane, the close approach to multiple planets. Stack these anomalies together, really look at them as a whole. Each one individually might have a natural explanation, but all of them together? How many exceptions does it take? Some argue that if this were a deliberately designed probe, why wouldn't it approach Earth, the one planet in the habitable zone? This is a fair question, but it assumes too much. Perhaps it's not a functional probe. Perhaps it's wreckage, tumbling on a trajectory determined by whatever disaster created it millions of years ago. Perhaps it's deliberately avoiding Earth. Perhaps whoever built it is long extinct, and this is just a ghost ship drifting forever. Or perhaps the skeptics are right, and we're seeing patterns where none exist. Perhaps this is just a very unusual comet, and we're letting our imaginations run wild.
Then it would have taken it 80 years to reach us. That's roughly the period over which modern science and technology were developed. So we just don't know if it's technological, where it came from, and what the objective is. But the point is, we made our existence known out to 100 light years from Earth.
But here's what keeps me awake at night: the cost of getting this wrong. If 3I Atlas is natural and we waste time investigating it as possible technology, we lose some resources, some telescope time. The cost is minimal. But if 3I Atlas is artificial and we dismiss it as just another unusual comet, if we fail to investigate because we're afraid of being wrong, afraid of ridicule, afraid of being associated with fringe theories, then we might be making the single biggest mistake in human history. We might be watching first contact happen in slow motion and choosing to look away. The scientific papers are careful. They use measured language. But if you read between the lines, if you understand the culture of scientific publishing, those words, exceptional, unprecedented, unusual, are almost screaming. In one paper, there's a supplementary figure, buried in the back, where researchers quietly acknowledge data they can't explain. This is how scientists panic, quietly, professionally, in footnotes and supplementary materials. On October 29th, 3I Atlas will make its closest approach to the Sun. Telescopes across Earth and in space will be watching. More data will pour in. More measurements, more opportunities to understand what we're looking at. Perhaps the mystery will resolve. Perhaps natural explanations will emerge that account for every anomaly. Or perhaps the anomalies will only deepen. We stand at a unique moment in human history. We have the technology to detect interstellar visitors. We have the instruments to analyze them in extraordinary detail. We have the knowledge to recognize when something doesn't fit our models. But do we have the courage to follow the evidence wherever it leads? Do we have the wisdom to take seriously possibilities that seem unlikely? The universe is under no obligation to make sense to us. It's not required to follow our expectations or match our theories. It simply is what it is. And right now, it's showing us something we've never seen before. 3I Atlas is not just an object passing through our solar system. It's a test of our scientific method, a test of our willingness to consider uncomfortable possibilities, a test of whether we can overcome our biases and fears to honestly investigate what might be the most important discovery in human history. The data is real. The anomalies are documented. The mystery is genuine. What we choose to do with this information, how seriously we investigate, how open we remain to unexpected conclusions, will define us. We are watching the skies, we are gathering data, we are asking questions. And somewhere out there, moving through the darkness between planets, 3I Atlas continues its journey, shedding metals that comets shouldn't shed, creating tails that point the wrong direction, polarizing light in ways we've never observed. Soon we will know more. Soon additional measurements will either confirm the natural explanation or deepen the mystery beyond resolution. Soon we will understand whether we are witnessing an unusual but explicable cosmic phenomenon, or whether we are seeing something that will change everything we thought we knew about our place in the universe. Whether we are watching not just a visitor from another star system, but perhaps a messenger from another civilization, drifting through our cosmic neighborhood on a journey that began long before humans existed. The answer is out there, moving through the darkness, and for the first time in history, we have the eyes to see it and the minds to understand what it might mean. We stand on the edge of discovery. The universe is revealing its secrets, one anomaly at a time. And the only question that remains is whether we have the courage to look. If mysteries like this fascinate you, if you want to stay ahead of the latest discoveries that challenge everything we know about the cosmos, subscribe to this channel. We're tracking 3I Atlas every step of the way, and when new data comes in, you'll be the first to know. Hit that subscribe button and turn on notifications. The universe is revealing its secrets. Don't miss what happens next.